Can I have the mic? Yes. So welcome everybody to this first session of the afternoon. My name's David Kelsey. I'm from RAL in the UK. And this is the session Up to the Clouds. If you're expecting a different session, I'm afraid you're in the wrong room. Today we're going to be looking at various issues, strategic issues of providing cloud services to the various members of the TERENA community in various ways, and also then looking at some of the issues of distributed data and policy and technical issues therein as well. So the first speaker is Bob Jones from CERN, where he is director of the Open Lab projects there, and he's going to be telling us about the Helix Nebula strategic plan for a scientific cloud computing infrastructure for Europe. So, Bob.
So good afternoon, everybody. I've hidden the keyboard so I can't see it. Let me just... What happened to all our slides? They all disappeared. Ah, there we go, okay. So again, I stand here not as a networking person, but from sort of a user community point of view, to tell you about an initiative that's gone on by a number of research communities of how we can change our computing models to potentially make use of cloud computing services provided by commercial suppliers, which is a bit of a challenge for us, and I'll explain to you what this initiative is and some of the points we're trying to address and where we expect to go with this in the future. So again, the origin of this initiative comes from the European Space Agency. I'm glad to say we have a couple of representatives from the European Space Agency here with us today as well. At a meeting of the IT leaders of the Euro Forum, which is the list of 8 European labs you can see across the bottom there, all involved, latest member of the European Exfel. And there we all said that with the rise of cloud computing, it's potentially interesting for us to understand how we can make use of commercial services. Places like CERN already have distributed computing models, so we're well aware of some of the issues involved, but they are still all publicly owned computing resources that we are making use of today. And we would like to understand if we can make use of commercially owned computing resources in that way. So it was presented by the European Space Agency at this IT working group in Frascati in Italy. And since then, we sort of CERN joined and EMBL joined the initiative as well. And there's been a couple of workshops hosted, first of all, by ESA in Frascati and in October at EMBL in Heidelberg, during which we've sort of developed this initiative and come up with a plan of how we want to see potentially how the research community can make use of such commercial cloud computing services. As part of that work, we have written a strategic plan document where we outline sort of 5 different objectives that we have for this initiative. So we want to establish a sustainable will be very important. We want it to be there for a number of years that can match the lifetime of the scientific instruments and infrastructures that we're putting in place. Put in place a multi-tenant in the sense that we don't want to be the sole users of this infrastructure. We expect other users to be in there in order to get economies of scale. A cloud computing infrastructure in Europe. We have a European focus to it, which is not exclusively European, but the initiative comes from Europe, and we want to make sure that it is available to us in a European context. So it's initially based on the needs of the European research area and the national space agencies. And the idea is based on commercial services coming from multiple IT vendors. We are not going into a one-on-one partnership with one company. That's certainly not the intention. We want to create a market of commercial cloud computing services from different companies, out of which we can cherry pick and tender. Okay? And of course, we want it to adhere to internationally recognized policies and quality standards. This is an issue in Europe since there isn't a global quality or legislation issue standard as well there. And with a governance structure which includes all stakeholders, not only the user organizations, if you want the sort of demand side, but also the service providers, the supply side. So again, this document is online, the link over there, it's an open access repository, so you're welcome to download it. I think it might be attached to the web page, and have a look at the contents. So the way we see this is it is a collaborative initiative in which on one side we sort of have the user organizations. We naively call that the sort of demand side, right? On the other side we have the commercial service providers, the supply side, and together as well we're trying to work with the European Commission and related projects. We realise work is already going on and we want to benefit from that work that's going in there. And also the European Commission is very helpful in terms of trying to make sure that we have a European level policy and approach. We don't want to fall into the trap in getting stuck into individual national issues. Of course they are important, but being the nature of the organisations involved, it has to work across multiple countries in Europe. And we hope to have that in place before we all hit the ground. The timeline that we've roughly laid out for it is during 2011, we did a lot of work through those workshops and writing that paper to try and sort of identify really what those objectives were and select a number of flagship use cases, and I'll tell you more about those as we go along. We identified an initial set of service providers, and there we relied a lot on the existing contacts that we have as organisations to bring on board a number of companies. And there the European Space Agency, with its existing processes for procuring resources, was very good and had good connections for bringing on a number of companies there as well. And also defined a basic governance model to get us going. Okay? And then we have something called a sort of pilot phase, which is sort of focus of the intense focus of the work we're doing at the moment, where we're trying to deploy those selected flagships, do an analysis of the functionality that we can achieve with those flagships, and in terms of performance, but also looking at the financial model. We're only going down this direction if it makes financial sense for us, and we have to be able to compare what it would mean in terms of the financial model of using these commercial services compared to other techniques such as having in-house, subcontracting, etc. and so on. Assuming that pilot phase is successful, we can consider building up to a full-scale cloud service market from after the pilot phase from 2014 onwards, where we would expect to have far more applications, even from our own organisations, spreading the possibility of what we do with our own services, adding more services, not just infrastructure as a service, but one might imagine moving further up the stack as well. Adding more users, of course. As we said, in order to get efficiency of scale, we don't want it to be purely just for these organisations that are initially involved. And of course, adding more service providers so that we potentially get a more efficient market out of which we can tender and procure resources as well. So this is the basic governance model that's been put in place for the proof of concept stage, which is the first part of the pilot phase, if you want. It's very basic, very simple. It's been agreed with all the partners involved, including the companies. So we basically have two parts to it. There's the underlying sort of users board. That's basically where people like ESA, EMBL, CERN and so on are sitting, and we discuss there. And that is a separate body, and there we are allowed to discuss in private without the commercial companies. So we can discuss issues that might arise we don't want to discuss with our suppliers. Okay. We have as well the service providers board, where all the companies are sitting, and they, of course, can discuss amongst themselves as well. And also there's a tech ARC group. So these are the guys, a small subset of those guys, where many of the SMEs are involved as well, where they're trying to come up with what is the architecture necessary for us to have this federated cloud or cloud that offers portability between multiple suppliers. They, of course, do talk to each other. And we have a small management team where there are at the moment 3 representatives from the service providers board and 3 representatives from the users board. And that meets once a week, and the information is sent out to all the partners in there. All the companies and organisations involved have signed a non-disclosure agreement, which has been developed inside the consortium. So I think we're up to about 18 or 20 members inside there. And that's the basic model we have. We'll look at it again at the end of 2012, see if we have to expand it, see if we have to reorganise it. But that's where we started, and it's working for the moment. Okay? Which is more can be said for this mouse. No, there we go. So the consortium includes all participating supply-side and demand-side companies and organisations. We have different levels of membership at the moment. So there's member status and adopter status. So the member status are ones that are actively involved in the flagships and their deployment. So either from a user point of view or from sort of supplier point of view as well. The adopter status, these are people who are very interested but are not actively involved in the flagship deployment at the moment, but they want to adopt what's coming out of it as well. And they've all signed a non-disclosure agreement, and we've introduced the idea of interested parties, people that want to follow but have not signed the NDA and are not participating, but basically want to get the sort of public information. There's no cost at the moment assigned to being a member, but of course we review the membership categories to make sure that people don't come in as saying they want to be a full member if they're not actually participating. Right? So we're expecting to add more members and adopters during this summer after the initial proof of concept stage, and I'll tell you a bit more about where we are at the moment. So during this pilot phase, which will last 2 years from beginning of 2012 to the end of 2013, we're deploying these flagships with the intention of looking at a number of key points here, which have come up as questions from the user side. First of all, questions of security, which are often seen as barriers to cloud adoption. So sort of actually understanding what is the level of compliance that's available from these service suppliers. There are a couple of organisations involved. We're working with the Cloud Security Alliance, who are helping us to understand some of these points as well. Reliability. We have production systems running at the moment when one thinks of, for the case of CERN, the WLCG, which is a production infrastructure running 24 hours a day, 365 days a year. Similarly for the systems which are processing satellite data and sensor data for ESA, same for EMBL and the genome sequencing. Those systems are running, and we have to be certain that if we do start tendering these services from outside commercial companies, that they can at least match the current level of availability and reliability that are achieved by our current production systems as well. That doesn't say it's 100%. None of those systems are 100%, and we're not expecting 100% from these companies either, but they have to at least match what we have. Okay? The whole question of data privacy, some of this is either sensitive or commercially valuable data, which will be moved in a cloud environment. How are they capable of doing that? What are the mechanisms that we're going to be able to do that? The question of scalability and elasticity. Everybody says, oh, it's great, you can just grow on demand. It's not always true when you talk to some of these companies, how much you really can grow and how much is really available to you on demand. And those are one of the things that we want to test in terms of the scale of some of these future research infrastructures, if they want to make use of them. And the whole question of network performance. Are there bottlenecks? What's the quality of service we have? CERN, for example, spends a lot of time working with the NRENS and EGI over the last 10 years to put in place the network links between CERN as a Tier 0 and 11 Tier 1 centres around the world. We test the quality and the performance of those networks. Is it capable of doing this when we're going across multiple suppliers? Can we still do that? Do they still have that sort of networking capability available to them as well? Those things are important to us as well when we talk of large-scale production usage. Integration. We know already that we will not be able to exist with a purely commercial service-based cloud system, at least from CERN point of view. There are a number of applications we will not be allowed to move out into the wild, so to speak, that will have to remain in-house. There may be specific business cases where it's more efficient financially or performance-wise when we want to share public and private computer centres. We may want to hold data temporarily in a commercial cloud environment, but permanently locally, or the other way around. Right? So we have to somehow have a hybrid approach where we can move data, identity, code, and so on backwards and forwards across this environment. And of course, we're all very keen of avoiding vendor lock-in. That we don't depend on any particular vendor for our data or applications in a singular sense once they have been transferred into the cloud. The whole question of exit clauses, what happens if the company goes bust, what happens if we change supplier, all these questions have to be addressed if we are going to tender correctly during our normal procurement processes to make use of these resources. And of course there are legal concerns, sort of who has legal responsibility for the data? Are you a data steward? Are you the data owner? All these questions, and many of the terms and conditions that you find in commercial cloud services at the moment are very, very vague on some of these subjects, and they're not aligned. Okay? And the whole question of transparency in terms of those conditions, the terms, the prices and so on, there needs to be a lot of work done there as well. So those are sort of questions we're trying to address. In terms of service procurement, assuming that we can go through this and we have to look at this, again, it's not just the technical questions we have to look at, but the whole process. So assuming it is successful, what would we have to do if we wanted to procure resources from such commercial cloud service providers? Well, some of the things have to be raised because of the nature of the organisations involved. CERN is an intergovernmental organisation, such is the case for many other ERO Forum labs. That means it's a question of jurisdiction. What's the governing law and arbitration rules that are used if we have a dispute over a contract? CERN is not bound by any national laws, right? We have a special arbitration clause. That has to be reflected in the terms and conditions for any services that we purchase. We also have tax-free status. That means we don't pay VAT, like many of the research infrastructures, international research infrastructures. That has to be taken into account in the terms and conditions. And also the question of return on investment. Many of these organisations are funded using your taxpayers' money, right? And we have to show from the member states that we are offering some form of return on investment for the money that those governments have invested in our organisations. So we tend to prefer, and we can procure from member states. So we would prefer to procure the computing resources from those member states as well. In the case of CERN, there's 20 member states. We should procure our resources from those 20 member states. Okay. And of course, we have to make sure there is a sufficiently large pool of commercial service providers that can respond to such calls for tender. It's no good if we write a tender specification or something that only one company can respond. We have to be able to get into a situation, and that's why we're trying to initiate this move, so there are enough suppliers that could respond to our tendering processes. Okay. And we don't believe that we can integrate the tendering processes for all the different laboratories that are potentially interested, or when one thinks about the different public organisations around Europe. Integrating it will not be possible. But we might be able to align on key points and have sort of templates which could be used by those organisations which have already been tested. So it'd be a lot simpler for labs and research organisations, universities and so on, to tender using those templates. Okay? And these could cover the technical specifications and standards, of course, and then the general terms and conditions which are acceptable to public organisations. Okay? The EC has published a sort of procurement and standards-based ICT elements of good practice last year. It's a lot of motherhood and apple pie, but it might be useful. We'll see how much. So looking at the specific flagships, as I said, we've selected some of those to test out the ideas. It's not just a paper chase, right? So we are actually deploying some of these things. So these are proposed by the demand-side user organisations, and they have to address scientific challenges with specific impact for society in general. So the whole point is that these should be high-profile applications which can sort of capture the public's imagination and attract other users, again, to get this efficiency of scale and usage. Okay? And they should be able to innovate in terms of either the functionality, what's being the services they're using, in terms of the performance, the scalability and so on, or even the business opportunities. A nice idea would be, can we grow this into some sort of platform or environment where other companies can offer additional services based on the data and the knowledge that's inside that environment. Okay? And of course, they have to be sponsored by the user organisations. This is not a free lunch. All right? We're not trying to get these things for free. At the end, somebody's going to have to pay. So these organisations must be prepared to contribute in two ways during the pilot phase already. In terms of manpower, we're not asking the companies to port our applications to this cloud environment. We're doing that ourselves. Or, in the case of some of the organisations, they are paying SMEs to port them for them. Okay? And also contribute in terms of the cost of procuring the resources. So we're paying cash as well to actually make use of those computing resources. As I said, it's no free lunch, and if it's going to be sustainable, we have to start with that idea from the beginning. Okay? And they must be prepared to participate in the costing exercise. As I said, it's very important that we're in a situation to be able to compare the cost of using these commercial services against procuring them some other way, i.e. in-house, managing it ourselves, subcontracting and so on. And to do that, we have to be able to deal with real numbers. And that's part of the costing exercise. So we can come back and say, well, it's really financially interesting for us to do this. Okay? Of course, if you're interested, send us an email, and you can consider to bring in an additional flagship as well. So they've gone through, and we basically They've been reviewed by the supply side, the demand side, looking if they're interesting, if it's capable of doing it. And we have 3, one from CERN, one from EMBL, and one from ESA and the national space agencies. And I'll tell you a little bit about those as we go ahead. So we selected these things as well, trying to make sure that we'd be able to address all the different criteria that we said were interesting for us to come up with a global opinion about whether or not it's interesting for major research organizations to make use of commercial cloud services. So there you see the 3 different applications. From CERN's point of view, at the moment, we're deploying part of the simulation software for the Atlas experiment on the LHC. We've chose that one because the data management needs are not as stringent as they might be for some other parts, such as the analysis work and so on. The genome assembly in the cloud from EMBL, this is very interesting as well because it has a very large memory footprint required for the certain stages of the workflow involved, and that they can break up that workflow. So that's pushing to some extent the needs on terms of server requirements as well. And of course the SuperSites exploitation platform from ESA and the National Space Agency is very interesting because this is sort of looking at the question of addressing natural hazards, earthquakes, volcanoes and so on, and pooling together different data sets, making those data sets available on this cloud computing infrastructure and providing additional added value services on top. So that's a very nice idea of what it could become in the future as well. And you see they each have different special cases to them, but across them as a group, we hope that we can address all of the points that are raised. Yeah. So the flagship deployments have started already, and what we're actually doing is we're taking each flagship, it started in January this year, and it's been deployed with each company in turn. Remember, these companies have never worked together so closely in the past. So there's nothing that exists between these companies. So we have to start already just deploying on each one and see what they really have in terms of cloud computing services. There you can see the initial set that's been going on with CERN. We started with Cloud Sigma, T-Systems, EMBL, T-Systems, Cloud Sigma, ESA with Logica as well. That's the initial set. We'll extend this. We expect to have some initial feedback and results by summer of this year, and the deployments have already happened. So the companies that have already been involved in the deployments actively, so there you see the companies as well. You see there's a mixture of the ones that already where deployments already happened, but also looking to do it again with Interroute and with Atos. And a number of SMEs there as well, like TerraDui and the Server Labs. They're working closely on with ESA on their flagship in terms of making sure the software can work in that environment, but they're not providing the infrastructure themselves. Similar thing for 6 Squared. They have some interesting technology there which could be useful in terms of deploying in a virtualized environment some of our applications. So what we actually already learned is that we have to have some special case in our consortium and how we work for working with these SMEs that's not taken care of at the moment. They're not really infrastructure providers, they're not users, there's some other case, and we have to refine our consortium agreement in some way to take into account these people because they're doing very good work for us, and we have to keep them on board and keep them happy and keep them working. Right. The whole question as well for us that's coming up as well is the whole question of network connectivity. We need to link these research communities, which in many of the cases have traditionally been used in the NRENS. We have to be able to link these to commercial data centers, right? Remember, we're talking about hybrid systems here, not just private or not just public. There has to be a mixture of them. We're used to using the services provided by the NRENS, and we want to see how can we bring that together. So, for example, the pilot phase deployments, as far as we're concerned, they offer a great opportunity to understand, how the NRENS could offer access to commercial data centers. We know it's a current question for you guys as well, and I refer you to one other talk I've seen about it from SurfNet in the same area, which is going to be presented, I think, on Thursday morning. So that's the sort of thing that interests us as well from a user point of view. We want to make sure these things are possible. And when we have multiple data centers, we're already working with data centers in Munich, in Amsterdam, in Zurich, and a number of other centers will be coming online as well. How are we going to do that connectivity? What's the policy? What's the rules? How's that going to work if we have to do that? Because we're doing it inside Helix Nebula, but I'm sure you guys are being approached as well from other user communities that also want to make of these such commercial data centers. So if we can try and address this problem together, it's something we can think about for the future. Okay. The European Commission have also said they're going to support this as well, so they've accepted a small support action project as well, which is not paying for the work we're doing in the flagships or anything like that. We're putting in our own money and so on, and it's not paying for the work that the commercial companies are doing either. But it's paying us to put in place the framework, the policy issues, make sure that the consortium can come together as a whole. So there, it's going to start next month. CERN's the coordinator. It's going to last for 2 years. It gets about 1.8 million EC funding. These are the companies and the user organisations involved there as well. So, that's basically just putting in the basic infrastructure, basic structure, I should say, for handling the consortium and the overall pilot phase. Right? And that's a way for us as well of making sure that the results come out publicly, that we can address the policy issues there as well. It's structured in this way, so you can see all the different, we're looking at sort of the governance models, the business models, and we're getting the companies to do this with us inside this project. And we're also looking at interoperation with the existing pan-European infrastructure. So here we're thinking about GEON, we're thinking about EGI, the grid infrastructure, we're thinking about PRACE and so on. What will be necessary to try and do interoperability with that in the future, looking towards this hybrid infrastructure of public and private resources. Okay. Again, I'll just relate this back to the sort of European policy as well. The GEON expert group produced their papers, very good papers, looking at Horizon 2020, the vision for 2020. And also then the E-Infrastructure Reflection Group give a sort of comment on it, and they have two nice, in their forward, they summarise very nicely the situation for us. And for me, I think the relevance of what we're trying to do inside Helix Nebula for the network community is it really does offer an opportunity for the network community to work with the research communities and commercial cloud service providers to deploy these flagships and investigate how such a public-private or hybrid cloud serving the research community could come into existence. And I'll finish just by showing you this last slide, which summarizes in one slide sort of everything we're trying to do inside Helix Nebula during the pilot phase, and the idea of listing all the other partners are involved, not only in terms of the infrastructure provision, but the overall model. Thank you very much.
Hello. It's due to non-disclosure agreement still and commercial participation, how much community can benefit from this work. And actually, cloud research and cloud is, commercial company is not much interested. What they did, they already standardized as intra-cloud standards, well developed, well supported. But community actually needs to create inter-cloud infrastructure for integration and interoperation. Will it will solved and how it will be given or how community can benefit from this?
Right. Let me tell you first of all why we also from the user side wanted to have a non-disclosure agreement. First of all, there are two key points. One is that the companies are exposing some of their IP to us, right? Their intellectual property. And they want to be protected that we aren't going to take it, distribute it, and other people make use of it illegally, so to speak. From our point of view, we don't want them to use our name without us agreeing as well. We don't want them to let them to use CERN's name, ESA's name, EMBL's name, and claim they're doing these things for us. So that's why the non-disclosure agreement is there. It keeps a sort of, it talks about those basic elements, okay? Now you say that the commercial suppliers are not interested in research. That's not the situation we've seen. They are very much. Well, wait a minute. I mean, I think this is one of the key points about this initiative, that we think we can create enough critical mass from a demand side to encourage them to worry about these inter-cloud aspects, right? When we tell them absolutely categorically, we are not going to make a contract with one and only one company, and we tell them potentially how much money is involved, then they become interested, right? And so that's the whole question behind this thing, creating this market. And if we can create enough critical mass of get it going, show that we are potential users of it, not just CERN, not just ESA and EMBL, but the research community. If we can show there's potential there for them, potential business on a sound business model, which is good for them and good for us, then they're interested. More
How do you foresee handling the contractual aspect, given the different nature of contracts across the European Union, where you'd have a subscriber in another jurisdiction that would want to use those services?
Yeah, that's a very good point. And I said it's one of the things we flagged that has to be addressed. There are a number of structures or groups inside Europe. So in London, there's the Cloud Legal team, which are looking at some of these points as well. And we're in contact with them to understand how we're going to put in point some of these things. I don't think we can wait for the European Commission to come up with a European-wide accepted policy on these things, because we're in an active geological place, but it happens on the same rate as probably the European Commission at the moment for these sort of subjects. So I think we have to move a bit faster than those people, and we will be looking at those. Again, it's a whole question, I think, of sort of member states involved from these organisations. These organisations are used to tendering in different countries at the moment, so we're going to try and sort of leverage that experience and try to bring together some basic terms and conditions for these things, but we understand it's going to be more a template than a set in stone set of instructions.
Yeah, I'm with Internet too in the United States, and we're finding that the providers have, in some cases, more experience on that contractual front, but that doesn't necessarily bode well for us on the demand side, in making sure that we're achieving the kind of contractual terms and conditions that are most advantageous to the research community. Yeah. So I can appreciate the European Union challenge. We have a similar one with 50 different states and each with their own jurisdictions. But
yeah, but that also comes back to the question to try and get a critical mass going as well, so that we do feel that the suppliers see that there is a big enough group that it's worth doing something for them. Okay. And so some of these points will be coming back to our next event, which will be held on the 5th and 6th of September, where we're sort of telling you the latest results about what's happening inside Helix Nebula as well.
Great, thank you.
So I think we've run out of time. We should thank Bob again. So there's a number of people sitting on the stairs here. I don't know if you'd like to try and just spend a few moments trying to find seats. There are plenty of seats in the middle if you wish to sit down. So while you're doing that, it's my pleasure to welcome the next speaker, who is Michael Dreescher. He is currently from EGI.eu in Amsterdam. He's got a history of working in industry and academia and working on grids and high-performance computing and many things. And today he's going to be telling us about EGI's approach to this cloud topic and federating clouds. And he's going to, the specific title of his talk is the EGI Cloud Infrastructure Platform. Now we need to find it.
Good afternoon, can you hear me? Good. Today we started with Bob telling us about European research institutions going for commercial cloud computing offers. I'll tell you a bit about what EGI is doing in that area and as a publicly funded infrastructure organization. So, to understand where we head at, we have to have a bit of a look at the history in the past. So, looking back 30, 40 years perhaps, it was computing really had mass. If you remember the times of mainframes and things like that, everything was hobbled around that like Earth hobbling around Sun, because Sun had much more mass and Earth was just circling around it. Computing was similar to that. And the applications were reflecting that they themselves had gravity. They were just not moving. They were very inert. It was very difficult to change them. It was the programming model, the development model was very, very slow and very, very incremental on that level. What then happened is that we actually got Linus Torvalds looking at the Linux kernel. We had MySQL, PHP, we had in general open source coming up as a completely different model of actually how to writing, maintaining, and deploying software. On the hardware side, Intel and AMD were looking at commoditization of network, and MirrorNet was coming as a specialization of types of networks. So that actually started to disrupt the whole IT infrastructure model. And that actually led to the opportunity to actually distribute, wide-scale distribute computing. And in the US, in the EU, grids were actually set up. That the term was grids to actually federate those local deployments of clusters into something larger that communities could use across their local cluster deployments. So that led to what EGI, at least in Europe, is today. We have a huge number of local resource centers federated into national grid initiatives. And our numbers are pretty impressive. We have in total more than 350 individual resource centers that are maintaining clusters for the research environment, for the research collaborations to use. In the more than 50 countries, we have lots of actual computing power and lots of storage that even by number, I can't imagine how much it actually is. So the next thing comes clouds. What does that thing actually do? It actually takes the commoditization process one step further. That whole infrastructures can actually be commoditized when you do it right. It's a lot of cloud talk and goes about virtualization without actually saying that, but fundamental to cloud computing, whichever level, whether you do infrastructure as a service, software as a service, or the most nebulous of all, the platform as a service, it basically all uses virtualization as one way of provisioning your resources on demand. So how are we going to use that? Is it actually a good business model that we should follow? We have the history of grids where we have developed a lot of technology and business models, how we actually serve our user communities. Do clouds do better than that? We don't know. Nonetheless, we have a lot of institutional clouds that are actually emerging that the institutes, the universities are actually using, toying with it, actually using for their local user communities to provision them with resources as they need that. So what do we need to do with them? This next step is logical. We are looking at federating those together to a larger landscape of cloud offerings, just the way we did it with grid computing the last 10 years. So on our way towards the digital era, we came up with an idea. EGI already is a wide-scale European coordinated network. It's a federation of national grid initiatives, and they in turn are actually federating the local resource centers who actually own the hardware, who own the physical infrastructure and operate that. EGI.EU, that's where I'm employed, is actually coordinating these national grid initiatives to provide a consistent access and operating model for the grid infrastructure as today. On top of, or underlying that, we have our distributed operation infrastructure. That means that the resource centers retain their authority and their ownership of all the resources. However, we coordinate them and provide the users a consistent way of how they actually look at the infrastructure. It's based around mainly accounting, monitoring, and service discovery, and actual support processes modeled around that. Other than that, most of the work is done at the resource centers in a federated, coordinated way. And in that, EGI integrates quite a lot of different resources. Most of them are based around grid computing, but we also integrate European desktop grid infrastructure and things like that. We integrate with Praise for the HPC community to provide the users, nonetheless, whether they use EGI or Praise, with the same experience that they used when using the resources locally. So what it actually does is we are already on the way of providing the researchers with what they really want. Instead of telling the researchers the old way, use it the way I tell you to use it, we're actually developing in a way saying we provide you with an environment that you need and that you are used to in the end. So we set up a task force for that to look at how can we actually federate these cloud resources together that are already emerging, and how can we integrate it into existing EGI infrastructure. We have a lot of experience in that field. We learned a lot of lessons with actual standardization, and for us, open standards that you can use or employ to actually access clouds in whatever aspect there is absolutely critical. That's one of the themes that you will see later on the slides as well. We already are ahead of cloud computing in that field. If you look back 10 to 15 years when cloud computing started, the first really reliable standards for cloud computing actually only existing for a couple of years. So it took around about 10 years for cloud standards to emerge and to actually be deployed on a wide scale. For cloud computing, we are already far ahead of that by a couple of years. People have learned that lesson. We are not the only ones, which is good, and we can actually leverage on those existing standards. But we are not there yet. Some still have to be created. However, we could think about creating one big cloud the way the commercial providers actually do it. For us, federating it actually guarantees openness, because we cannot command one particular cloud to go into the direction. We have to look at the coordination and the agreement and the consent to go a common way. And in the end, we do not need to reinvent the wheel. There's a lot of technology already out there, a lot of cloud technology, a lot of infrastructure management technology, and we use the cherry picking, looking at what works best, what EGI already has heavily invested in as infrastructure management software, and make it work together. So this task force has a couple of objectives. One of them is writing a blueprint for user communities to tell them how they can engage with us, how they actually can make use of federated clouds. Part of it will be describing resource centers, resource providers, how they will, or what they will have to do in order to be able to join that federation, and things like that. And we're actually constantly maintaining a testbed where we're actually looking and deploying the software that runs a federated cloud infrastructure. We are a pretty diverse community within that Federated Clouds Task Force. We have 23 institutions over 13 countries within the European Union. This task is led by Oxford E-Research Center and the EGI.eu by Matteo and by me. We have quite some different stakeholders. Most of them are resource centers that are actually providing those resources. 7 entities, 7 individuals representing technology providers for OpenAirBuilder, OpenStack, and such like, that provide us with the software that we need to set up a federated clouds infrastructure. And a couple of user communities and liaisons to key communities such as standards development organizations and bodies like that, to actually ensure that we have the right standards that we need to build our infrastructure. Our strategy is looking at clearly at providing a federated infrastructure as a service cloud, where you see that the individual national grid initiatives are actually providing the individual cloud services either by themselves or through their own federation of resource centers. We are open for commercial inclusion, and this is actually where we do see the complementary function of Helix Nebula and EGI in those activities, where Helix Nebula looks at the commercial aspect of actually using cloud resources for research collaborations. We are looking at the publicly funded e-infrastructure aspect of the whole thing. There's some commonalities, a lot of them you may have already spotted, but there are some differences that are actually quite important, and we have to look at that those are not hindering communities from using either or the other. And in the end, which is much more from our perspective, much more easy to deliver to the users as opposed to common software stacks, is that we actually provide the users with what they want. Their applications that they have developed don't really need to be gridified. It's a term that a lot of people have used in the past, that they have to be significantly be rewritten to actually match the grid middleware that has been deployed over the last couple of years. But these applications can pretty much, as they are, be used in a cloud environment when it's done right. So that infrastructure platform, what does it consist of? We have identified 6 basic key capabilities that any cloud needs to deliver to be able to enable the users to do with it what they really want to. And these are the 6 pretty much down. There's no rocket science in there. Virtual machine management, data management is very important. Information discovery, which clouds are there, which services are there, and where are they located. Accounting, monitoring, and notification are more backplane services that are actually required for us to actually operate and manage the cloud infrastructure, and for you to actually look at, in the end, how many resources do you have used. This is then federated. Many different resource providers provide the same service with the same interfaces, and we have a couple of global services within EGI, accounting, monitoring again, and some notification that you can actually tap in irrespective of which actual resource provider you are using. We are looking at federated authentication and authorization infrastructures and how to actually have those cross-cut through all the cloud services that we have to provide. And there's some marketplace where communities can actually start sharing virtual machines and appliances and their experience coded in software and in virtual machines to actually reuse them across communities. The testbed is constantly monitored according to this, reusing actually the monitoring infrastructure that EGI already has. Some of these services are popping up and down. This is currently at the moment not publicly available since we are not as mature as we would like to. But it already leads the way towards how we can actually transition that new technology into a production state. And a lot of lessons learned come from that and will feed the way into how we actually provide the services in production level. So how does this fit into the overall EGI strategy? So far it was all hanging a bit tight and no real ties towards the overall EGI strategy, and this is embedded in that way. EGI obviously is all about communication and coordination of the various different stakeholders, of the resource providers, of the user communities, and the software providers for the software that we operate on the user's behalf. We are mainly coordinating the operational infrastructure that's delivered by the resource centers in the field that are federated international grid infrastructures. These are used by individual researchers and large research collaborations such as the WLCG, such as VNMR and other communities that are affiliated with EGI. Currently, and this is what currently EGI is doing, this is this virtual research environment provided for the large research collaborations that we are supporting, operated by EGI and integrated by technology providers with the software, with the scientific applications coming from the research collaborations themselves. We provide a collaboration platform with which we enable the communities to actually work with each other, which features something like the application database where communities can provide their own scientific applications or customizations of existing applications that serve their purpose for their own research domain that other communities and collaborations could use. Trainings are marketed and advertised and coordinated through this collaboration platform as well, where communities can provide trainings on such applications for other communities, where technology providers can provide trainings for the software they use for collaborations to actually integrate with their software. Next to that is EGI is also integrating existing research infrastructures, such as the ones coming from EMBL or EBI, who already have large infrastructures up and running, but they would like to integrate with EGI in terms of operational management and monitoring. This is something that EGI is doing as well. And next to that, oops, where is it? We are providing the Federated Clouds infrastructure as yet another resource and service type to our users for those who need that and for those who want that. And on top of that, the research collaborations actually themselves start to assemble and deploy their own individual virtual research environments, integrate them and operate them on their own, because we provide them with a generified infrastructure view of the resources. And once we've done that for one, we can leverage on the economies of scale and actually deploy and provide those resources for any collaboration following the same pattern. And quite obviously, we are located in that area of EGI strategy, and the various different resource providers are actually running the cloud middleware, the cloud stacks, providing the key user-facing services, and providing embedded into the backbone the operation infrastructure of EGI, accounting, monitoring, and notification services. And next to that, part of the collaboration platform is actually this virtual machine marketplace, which is run and used by the communities themselves. Federated authentication authorization infrastructure is clearly part of that collaboration platform as well, where we see that actually as a little split. We see there will be two such infrastructures be required, one for the actual access and management of the cloud infrastructure itself, and one that might be the same but might be different as well, that depends on the actual requirements, for accessing the actual services deployed within the individual virtual research environments. So, looking at that, how do we actually get this federation done besides from process and policy? There's also some technical bits that need to actually be achieved to actually make that happen on the day-to-day basis. The standards that we have so far identified and are actually partially already in use is for virtual machine management, not very surprising, OCI 1.1, sorry, should be 1.0, that's a typo in there, 1.1 doesn't exist yet. CDMI and OVF is something to manage storage and actual appliances, packaging up your virtual machine images and coordinating them together into one set of services that make sense. GLUE2 and LDAP3 are used to actually set up a distributed information system infrastructure. Certificates are used at the moment for direct infrastructure access, that is for you to manage your virtual machines, to manage your cloud, your storage infrastructure. OGF usage records and the upcoming extensions for storage accounting are used for actually cutting accounting records for your cloud infrastructure, very much the same way as it's done currently for grid infrastructure. For notification, we're using a different set, email, messaging infrastructure, Twitter, things like that, to actually notify you of something that's happening with your cloud instances. These are actually implemented and provided by various different technology stacks, OpenNebula, OpenStack, Eucalyptus, things like that. For monitoring, there is nothing really existing as a public standard that you could actually make yourself free from any specific implementation, at least not in the way that we look at. So we said this is one of those that we have to mandate the resource providers to actually use and integrate with Nagios, a specific tool to provide monitoring. Looking at that, you might wonder who's actually doing what in all that business. Something that wasn't very clear in the grid business is perhaps more clear in the networking business, but in the cloud, it's very starting to emerge to be very, very clear who is actually doing what and for what reason. So infrastructure providers pretty obviously own the resources. They may own the computing and storage resources. They probably lease networking resources from the NRENS and from other providers. And they're deploying certain stack of software. In the grid world, it's Unicore, it's GLAD, and things like that. In the cloud business, it's OpenNebula, OpenStack as that. They own and operate that on top of their physical infrastructure to provide a particular service to their users. On top of that, the research communities are to deploy their own virtual research environments based on virtual machines. And it's very important to actually note and to make it explicit that the research communities are the ones that own their own research environment. They are responsible for that and nobody else. That doesn't mean they have to do everything that's attached to that, but they are the ones that own that. These virtual research environments may or may not be operated by the same research collaboration. However, they may say, we can't do that, we don't want to do that, that's not our core business, our core expertise. EGI, please do that for us. But by simply separating that out, it actually gives people the awareness that there's actually some effort and time attached to that to operate those virtual environments for those user communities. The next thing is communities. Some large communities have enough expertise to actually write their own software. Some small communities or even individual researchers don't. So they probably have to go out and look at other means using open source, using, other collaborations, tap into EU projects to actually have certain parts of their virtual research environment written by others. Or actually integrated by others. It's these platform integrators that use existing software or write it themselves and actually make it happen that it works within their virtual research environment. That's typically what software engineers talk about. It's glue software when they integrate software with each other. In the end, something that people also often overlook is actually classic software engineering business. Some companies, some research institutes that actually write the software, maintain it, provide support for the software is actually part of that community effort as well. These guys have to actually, at some point, have to get some cost recovery for their work as well. You can't really say that all that stuff is gobbled up in one research community. You have to make clear who, even if it is all part of one community, you have to make clear who is doing what in the community and gets what in return for what they're doing. So there no doubt are a lot of questions. We haven't solved everything. We need help with that. So we need actually help from Gian, from TERENA and other communities, thank you, that can help us solving certain problems. You probably haven't seen, I haven't talked about networking. It's pretty obvious why. In cloud computing, cloud compute resources are fairly mature and very well understood. Cloud storage is lagging a bit behind in terms of maturity and standards and how you actually use it and for what. What's missing is really networking as a service. It's the on-demand provisioning of a certain network. Certainly when you look at federating clouds together, the provisioning of links between the research centers, the way the user community is needed, because they use more than one cloud provider at the very same time. So network configuration and provisioning has to happen much more on demand and much more on a self-serve mechanism that's used today. So our next big event where we actually would like to talk to you guys specifically and more focus is the EGI Technical Forum in Prague from 17th to 21st of September. On there we have a dedicated track that spans 4 days over virtualized resources. The first one is actually for resource providers, telling us what they do and what they failed to achieve, actually to explicitly make clear which problems they have and asking for help how to solve that. The second day is more for those technology providers, those that provide cloud management solutions, like OpenNAS, like OpenFlow providers, like OpenNebula community representatives or OpenStack representatives that tell us what do we have there to solve your problems. Which services are actually necessary to actually make use of an infrastructure as a service cloud, whether federated or not, to actually allow the researchers to make the most out of that. Just stopping virtual machines doesn't get you a lot of mileage. It's these high-level services, that user-facing services, that really help you to automate the management and operation of your own virtual research environment. And last but not least, looking at scientific software, how compatible with clouds is it? Are there any best practices or software patterns that you can use to write your application to make it by itself the most out of a cloud infrastructure? And with that, I'll leave the last takeaway key slide a lot. I have to thank Matteo for his valuable work with running the Clouds Task Force. We are using a lot of expertise within EGI to actually make it happen. Cloud computing is not a magic bullet, but it's not something that you have to reinvent the wheel for to actually make it running for your users. Thank you.
So thank you very much. It's time for questions, discussion. Yes, we have a question here. Just wait for the microphone.
Fotis Karagiannis, one short question. So EGI.eu would have been ideal for procuring some commercial resources, so I mean public clouds, satisfying some cloud bursting needs, or maybe, the so-called long tail of science, so individual users or small groups that whose requirements are not taken into account. But I haven't seen that in the presentation, not in the, neither in the EGI strategy document. Can you comment on that?
Right. It's as far as I understood, it's actually really two questions. First is actually looking at the integration of commercial cloud providers. I leave it to your judgment. We had contact with commercial cloud providers, and we had large discussions on how we actually set up this cloud federation. Our approach of openness and federation as individual responsibility of the resource providers came along with actual commitment to publicly available standards, which would have meant that existing commercial cloud providers would have to invest certain manpower and resources to actually make that happen. That didn't happen, so they decided to retreat from that effort and said, now we try to go for another approach, certainly because they saw, perhaps in the commercial world, not so much uptake of OCI as a virtual machine management standard or actually cloud computing interface standard, as it may be now. There's, for example, OpenStack itself is backed by several large cloud computing providers who use that as an open source effort to actually get improvements into the stack while using that by themselves. So large commercial providers will, in due time, provide OCI support natively on their own resources. In terms of the EGI strategy, sorry, I got distracted. So, yes, coordinating is a two-sided sword, really. You can cut yourself tremendously with that. It depends a lot about what the resource providers actually are willing to relinquish in terms of their own control and power for a leading body to actually coordinate and lead in that respect. So we have to be a bit careful with what to actually say in terms of the EGI strategy. It's not driven by EGI.eu, it's actually driven by its members, by its NGIs, much more than actually by EGI.eu.
So Paul had a question.
So maybe I can just add a comment to lead on from the question. In some of the discussions we've had with the companies in the context of Helix Nebula, having a publicly funded body which is not tied to any particular country, in the case of things like EGI.eu, is seen as attractive to them as well, as a sort of neutral player who can help in some sort of this negotiation and brokering process as well. So I think it's a good possibility, and it's something that could be further investigated. Your assessment of the standards issue, that is very much true. None of the companies we talked to were interested in OGI. They might have been interested in OpenStack, but above all what they're interested in is that they will have their own software stack and they will be prepared, if there's enough of a market, to offer compatible interfaces. But don't ask them what they're doing below the hood.
Well, to go a bit more technical on that, we had really heated this interesting but also heated discussions, very emotional discussions on the various different deployments. There were actually a lot of you may know about JCloud, an API that actually is integrating, providing a common API, which on the back end is actually integrated with many different proprietary cloud standards. We had a similar thing actually, or is a similar software is actually available as a fronting service, providing OGI compatibility, while it has a plug-in interface to the local cloud management stack that's actually provided by GWDG in Germany and is part of the Open Nebula stack. That's the OGI server. Similar as, say, the Globus people do it with deploying GridSam in front of Gram. But even that was seen as something not attractive at that point in time to commercial companies. It might be different now, but it was back at that point in time not attractive enough for them to actually take up. However, our goal is to have or achieve compatibility with commercial cloud providers so that user communities actually are able to use both a publicly funded cloud-based infrastructure and commercial providers for their needs when they identify them, requiring commercial providers to solve their needs.
Okay, I think time has run out, so we should thank Mikkel again. So thank you very much, Mikkel. So the final talk today is a slightly different topic, but clearly related. It's a pleasure to welcome my colleague from STFC, Juan Bicaregui, where he is the head of the eScience Center there. And he's going to tell us about building an open data infrastructure for science.
Thanks, David. Okay, so good afternoon, everybody. Indeed, the last two talks were about clouds, and mine is veering a little bit off from the clouds. It's not networking, it's not clouds, but it is definitely about data and openness and about building an infrastructure. I'm Juan Bicaregui from eScience at STFC. So the talk's in three parts. I'm first going to tell you a little bit about what STFC is, what we do, why we do it perhaps. Then I'm going to talk about practice, a particular project, the Pandata project, which is a collaboration of 13 photon and neutron sources across Europe, Bob mentioned in his talk earlier. And then about policy, and in particular some new data policy principles that have just been published by the research funders in the UK. And I think it'll be fairly obvious how that is relevant to building the data infrastructure. So firstly, an introduction. What is STFC? Well, it basically funds different aspects of one particular area of disciplines within science in the UK. In particular, we give grants in particle physics, nuclear physics and astronomy. But we also run large facilities like the ones at the Rutherford Appleton Laboratory where I'm based. This part here is ISIS, it's a spallation neutron source. The Diamond synchrotron is the UK's national synchrotron there, just to give you an idea of scale of this aerial photograph, which is slightly out of date. We don't take them every day. That's a 250-meter diameter to that synchrotron. We also have a very high-powered laser facility there where they blast a reasonable amount of energy in an unbelievably short space of time into an unbelievably small spot to smash to smash the sample into the very tiniest parts. Our old computing center was there, and our new computing center is actually a green field in this photograph here. We now have a very modern machine room with lots of nice equipment in it there, which I'll tell you a little bit about later. We also have a sister laboratory up at Daresbury, and we also fund the UK involvement in the European synchrotron, the ESRF, the European Neutron Source, ILL. We're the funders of various astronomy projects, including the Square Kilometre Array, which is coming shortly, and the UK part of the Large Hadron Collider in CERN. So all the big science, and what is the science? Well, we do well in that picture there. I won't go through them all. You'll see it really covers a very broad range of sciences. But I'm going to talk about the kind of science that we do at the facilities here, really. So the facility, like ISIS there, is a neutron spallation source, accelerates protons, hits them into a target, which then does a shower of neutrons, which is used to study the materials. And typically, this is the target where the neutrons hit the target and spray neutrons. Protons hit the target and spray neutrons out. Then the users come and visit and put something in that beam of neutrons. Here somebody has a piece of an aircraft wing. More typically it's a small sample of some material that we want to know the molecular structure of. And then you do some data analysis on the diffraction pattern that you get out and infer something about the materials here, the longitudinal strain in the wing. The applications are very numerous, and I've got a whole load of flashing by things here. We look at semiconductors, we look at hydrogen storage, we can look at the particles within muddy water, we look at the magnetic moments in magnetic media, the strain in a wing, as I said. There are many, many different types of application that we can do, and too many to go into, really. So it's really a multidisciplinary facilities where the different disciplines are all benefiting from the same underlying technology. So for the purpose of this talk, I'm really going to talk about the data infrastructure rather than the physical infrastructure, and I'm going to build up a data-centric view of the research process here. So with data at the center, and of course the data isn't one data set, the data is data collected from many, many different disciplines and data sets from different experiments. And then if you look at it from the data-centric point of view, well, you create some data, you store it for a while, and then you need to access it later. And underpinning all that, there's all the e-infrastructure, which a lot of the people here are focused on. Now, I've laid this out in this way, particularly because if you think of this from the user's point of view, the user is really interested only in the horizontal axis there. They want to put data somewhere and then collect it later without worrying too much about what's done. Whereas the infrastructure providers, perhaps a lot of the people here are concentrating on the lower part. I myself is more involved in the upper part here. But the infrastructure providers really have to make sure that the data is kept until it's needed. And in an ideal world, if the researcher really got what they wanted, they would have to know absolutely nothing about that blue part of the diagram there. If we do our job well, that blue part can disappear as far as the research is concerned. And that is quite a taxing objective to set ourselves. Just looking at the different parts of the life cycle, we've rather conveniently formed it into 7 Cs here. You can begin anywhere in a life cycle, but maybe let's begin here in the top left. Some scientists get together, form a collaboration to do some experiments. They do the experiment to collect some data, create some data. They have to store that in some capacity storage. They'll probably do some analysis or computation on that. They'll need the results of that computation curated to underpin whatever publications may come later. They often want to collect different data collected in different ways. So one of the things we're trying to concentrate on in the project that I'm going to present later is about bringing data from the neutron source and the photon sources together, because they give you different aspects of the materials. So you want to collect together different data sets perhaps and then communicate the results of your experiment in the literature or however, and that itself triggers new collaboration. So I'm just going to give us a very quick mention of some of the things we do supporting each of these stages. On the data creation side, we've been putting a lot of work into our infrastructure recently, trying to link the systems that are ahead of the actual experimentation. So from the proposal submission system through to the management of users when they arrive on site, through to the data acquisition systems, trying to make sure that we don't have to retype any of the metadata there, so that the data that's entered in the proposal is then carried through, so that when the user turns up, we already know what the sample is, what the experiment they want to do, what the instrument parameters are, all from the proposal system are already there and ready for them. Similarly, the data acquisition system's already parameterized and tuned to the particular experiment. And that metadata can be carried from each phase in the research lifecycle I was just showing through to the next one. On capacity, this is a slightly old graph there that it shows that for us, Moore's Law is about 15 months. We had 1,000 times the data in 2010 than we had 13 years earlier, so 1.3 years is Moore's Law for us. It doesn't sound that different from 1.5 years or 2 years, but in fact, over that period of time, it means that we've got 10 times as much as we would have had if Moore's Law had been 2 years for us. So I said that data's 2 years old, but if you put today's data in, we're at just a little bit short of 20 petabytes at the moment, so it's pretty much continuing that straight line a straight line on a log scale of doubling every 1.3 years. Computation, there are many different things that we want to do. We want to fit experimental data to some particular model. We might have some very compute-intensive applications that we want to farm out onto a cloud or a grid. We want to do diagnostics in real time. This is actually the unbelievably small spot of light that's coming off the laser, and just looking at the different intensities across a particular diameter of that to see the behavior of the laser so that we can fine-tune that. We might want to do some theoretical calculations about the laser as well. We want to keep that data for a long time. Again, this slide is slightly out of date, sorry, but just as a point of comparison, ISIS was started 25 years ago, and we've got 3 million files that have been collected over this 25 years. Diamond, in its first 2 years, collected 11 million files, and we're now at more than 20 million files. This is basically pictures, photographs that are taken of one sort or another of the diffraction pattern as the photons go through the material. We provide services for a whole breadth of other services as well. A core part of our data lifecycle is really the management of metadata, and the ICAT is a system that we've got, stands for Information Catalog, which really is the hub of this passing of metadata through the lifecycle. So when the proposal comes into the proposal system, various bits of metadata are pulled out into ICAT, which are then made available to the panels that do the approval, and then for those experiments that get scheduled, they go through to the scheduling, more data is added. All of this is fed into ICAT so that when at each stage, the data can be tagged with whatever metadata is needed to make most sense of it, right through to the publications at the far end. I think this almost goes without saying these days. Users are coming with extremely high expectations of how easy things should be to do, because they're used to seeing the benefits of absolutely massive investments that Facebook and Google and all the rest of them have been able to put into their services, far, far in excess of whatever we can put into ours. So expectations are really really very high indeed. Collaboration. Well, this is really into the talk that the second half of the talk that I'm going to give you today is about the pan-data collaboration. Obviously, if you pick the different photon and neutron sources across Europe, the kind of infrastructure that they each need to provide is pretty similar. So we're putting a lot of effort into trying to provide the same technological components there. Moving on to the particular project, pan-data. So pan-data is a collaboration. It was 11 partners in the European project, but now 13 partners in all. The 2 more have joined. These are basically the major photon and neutron sources across Europe. And together, we have about 30,000 scientists visit us each year. These aren't people using some web application. These are scientists that are actually coming to visit the facilities and spending a few days with us while they do their experiment. The vision behind Pandata really is about, as I said, sharing technology. The kind of legacy that we are building from is where each of the different facilities each had a different infrastructure supporting the data pipeline. And our objective is to put in place common technologies for the various stages, for the capacity storage, for the software repositories, for the data repositories, and for publications, so that we can federate all those catalogues and provide a single federated catalogue for our software and our data and our users across the collaboration. Not only will that give us benefit because we can share the technology, but also give benefit to the users, because when they come to the facility, if they've been to one of the others, they'll recognize the systems that are put in front of them. And we've actually done some work at trying to find out how many users are using more than one of the facilities, and about 20% of the users are using more than one facility. So it's a very substantial body of people who would benefit from having a single experience at the different facilities. The science driver really is about putting the data from different types of facility together. If you can put neutron diffraction and X-ray diffraction together, the X-ray diffraction gives you the position of the heavy atoms, and the neutron diffraction is particularly good at giving you the position of the hydrogen atoms. So you can get very high quality structural refinements and NMRs for the bond lengths. So we're not yet working with NMR facilities, but we're already getting benefit from bringing neutron and photon data together. We've just finished in the last few months the first project in the Pandata collaboration, which was really about standardization, not developing any technology. And we looked at 5 particular areas about data policy, and I'll come on to data policy later, but we've been defined a draft common data policy across the facilities, so that doesn't get in the way of us sharing technologies. You need to at least have a common framework so that you can implement common technology. Sharing user information is another important area. A lot of work's gone on with that. We're also collaborating with the federal ID initiative that Bob Jones was talking about earlier this morning. We've done a lot of work on standardizing scientific data formats. That's also pretty important if you want to be able to share data across facilities, if you want to allow the users to use the software that was developed for one facility on a different facility, and on that software itself, trying to work towards enabling software. The current situation, a lot of the software is developed for a particular instrument on a particular facility, but in principle it could be used on other instruments if you can do the right standardization. And integration and cross-linking, this really is about the ICAT that I was saying. It's about integrating along the life cycle so that everything is linked front to back. As I said, those 4 areas really, the users, the data, the software, and the integration were all standardization done under the last project, and now we're working on the Pandata Open Data Infrastructure project, which began at the end of last year. The federated user catalog is something that we're building a service now, the umbrella system that was also mentioned by Bob earlier, and that will be in production pretty soon now. The data catalog, again, federating the data catalogs against the facilities will at least will go into service across some of the facilities pretty soon within the next half year or so. And then we'll build up from the pilot phase with having a few facilities up to the rest of the consortium. The other areas are a little bit more research-oriented. Provenance is really about being able to track the analysis of the data stage through its analysis stages. So knowing that this derived file was derived from these 3 raw data files using that piece of software. This at the moment is something we're not tracking. Obviously, for the sake of being able to follow the provenance of data, we want to include that kind of information in the ICAT, in the information catalogue as well. Long-term preservation is an area that is necessary for data policy reasons. And a new line of work we've started is about scalability with the new generation of instruments are really very demanding in terms of the data rates that they can generate with frame rates coming off up into the gigahertz now are being talked about. So if you're taking essentially pictures of the diffraction pattern at gigahertz rates, you collect very high levels of data very quickly. We're going to implement these different things in test cases, one in powder diffraction, one in small angle scattering, and one in tomography. So going back to this diagram that I showed you earlier, and looking at that and seeing what have we done already and what we've still to do, there's an awful lot of initiatives, some of you in this room will be involved in them, on the underlying low-level sort of e-infrastructure. We've been doing a lot of work on metadata catalogs over the last maybe 5 years or so, trying to streamline this carrying forward the metadata that's collected in one place and using that in other parts of the life cycle. There's lots of portals out there. We built one ourselves called TopCat, which because it sits on top of the ICAT, but there are many others out there. Those will always be kind of discipline-specific ways of accessing the data that's relevant for an individual. But what do we have on this side? I think this is where we need to do some work. As I said, we've already got feeds in from the kind of user management systems that the laboratories have got, feeding into the whole system. We've got feeds in from the data acquisitions systems. What we need now is also to get feed in from the data analysis stages so that we can tie the whole thing together and develop sort of provenance research where the outputs can be traced back through the analysis phases all the way back to the experiment. Okay, so moving on to the last part of my talk about some data policy principles that RC UK is the Research Councils UK, which is a body across the 7 research councils that fund different disciplines of science in the UK. And last year we came up with some harmonised data policy principles, which was really quite an achievement, I think, because it's to capture what are the essential principles behind the data policy in different disciplines is quite an achievement because the demands are different in different disciplines. And I think we've captured 7 principles which underlie them all. So the first 2 really are about the data. I'll talk very briefly about each one of these, about data being a public good and about the need to preserve data. Next 2 are about access and how discoverability and access to the data and confidentiality kind of tension against each other. The next 2 are about rights, the rights to first use for the researcher compared with, and the rights for the researcher to be recognised for the work they've done. And of course, there's always something about costs. I'm going to quote the actual text of the policy, and I'll give you some of my words. I was chaired the group that came up with this, and this is, so the expression of views is my own. The text of the policies are the official line. But before I get into the actual detail, I just wanted to say something about why is it that we want these at all? Why would we want to preserve data? Why would we want to access data? Well, firstly, we might want to repeat an experiment so that we know we can validate somebody else's results. We might even want to repeal an experiment. We might want to say, actually, no, I differ with the interpretation that they gave for whatever reason. We need to be able to see the data. Or we might want to repurpose the data for a different piece of study. And it's well worth thinking about those 3 things separately because the demands that they place on the metadata, on the data access, are very different and more stringent as you go on. To give enough information so that somebody can repeat an experiment is relatively simple. To give even more information so that they can validly know whether your analysis was valid, that's more about the analysis phase, so that gives more demands on that sort of computation stage of the life cycle. To actually be able to give enough metadata about the data so that someone can use it for a completely different field is even more demanding. There's all sorts of gotchas in there where if you're not careful, you release some data, but in fact, because it's taken into a different domain, you make false assumptions. So very quickly, at less than 1 minute each, these 7 principles, data are a public good. And most important thing here is the term a public good. Technically, a public good means that something's non-rivalrous and non-excludable. Non-rivalrous means that if I consume it, that doesn't take it away from the possibility of you consuming it. Well, it's kind of obvious with data that you can make a copy without consuming it. Non-excludable means basically that nobody is denied the possibility of accessing it. So that is already a very bold statement. It's very similar to a statement that came out from the OECD some years ago. It's slightly stronger if you look carefully at the text. Publicly funded data are a public good, so that's already a very big statement. Produced in the public interest, which should be made openly available with as few restrictions as possible in a timely and responsible manner without harming intellectual property. The other points here I will come on to in the other principles. The second one is about the fact that data should be managed, and the important thing here is that each project, as it were, should have a data management policy and plans in accordance with the relevant standards and best practice. It's impossible to say what those will be across different disciplines, but it is possible for us to say, well, whatever it is, you should write down what you're going to do with your data, and that should be assessed as part of the peer review process in the same way as the rest of your experiment is assessed by peer review. And one of the things you would hope is that we'd say, well, we're not going to lose data by accident. We're not going to keep all data forever. Some disciplines might. If you're collecting environmental data, it may well be a policy that you want to keep it forever. In other disciplines, you'd say, well, it's not worth it. But the point is, we're not going to lose it by accident. Data should be discoverable, and that really is about putting enough metadata out there so that people can know whether that's useful for them. Sufficient metadata should be openly available. The openly available is slightly stronger than the text that was used about the actual data. The actual data can be behind some kind of registration, not to restrict access, but to enable logging and knowing who's taken what data. So sufficient metadata should be openly available to enable others to discover that data and at least ask the question whether that data is useful for them, and then go through whatever procedure might be necessary for them to get it. If they're authorized, there may well be authorization. For example, data may be protected. There could be legal, ethical, and commercial constraints on the release of data. That's certainly the case. Ethical constraints are very important in some disciplines, particularly in the medical area, of course. We did some work with some longitudinal cohort studies where protection of the cohort participation is very important. We've been collecting data about a particular cohort of people for 40 years, and they contribute perfectly voluntarily to this data collection. You don't want to suddenly lose your cohort just because some piece of bad publicity happened. Originators may have first use. Notice may be entitled, depending on the discipline, but if they are, then there'd be some limited period of privileged use for those. And the length of that period will vary according to the disciplines. We're talking now a norm of somewhere between 6 and 12 months, but it will vary enormously up to perhaps 3 or 4 years, which might be needed in some areas. Reusers have responsibilities too. If you want to use somebody else's data, then you take on responsibility for doing the right thing, basically abiding by the terms and conditions of that data. If you're given access, there may be terms and conditions associated with that. Openness doesn't necessarily mean you can do whatever you like with it. For example, there could be ethical or consent constraints with what's done with the data. And you should acknowledge the source of the data as appropriate in normal scientific practice, but that's certainly the case here as well as with publications. And then lastly, about costs. Well, data sharing is not free. It's going to cost somebody along the line something. And this is really a recognition that the UK Research Councils accept that there is a cost associated with data sharing, and that will be borne as part of the cost of the research along with the rest. So, of course, you can ask for funding, but that will be peer reviewed in the same way as everything else that is funded. I'll skip this because I'm a bit short of time. I'll just give one last picture, a final thought. Those 7 Cs, a lot of the talk about data management is really about this part. It's about permanent access to data, and it's about the creation and storage of data, and then about the curation and collection of data together. What we're particularly focusing on in the Pandata ODI project is about this getting provenance research by including the computational stages there that link up the sort of data as it was created and the data as it was published in the paper, and being able to trace through there. And that just leaves the final little bit at the top there, which is really part of a kind of VRE type work in order to complete support for the whole data lifecycle. Okay, thank you.
So thank you very much. We have time for a couple of questions. There are any? Yes, Yuri.
I don't want to be usual suspect to ask questions, but still a very interesting presentation. And actually what we also learn from studying the European documents and data and future data is completely matched to this. But my question is, you are talking about reuse, reprofiling of data, but still in data lifecycle, it's not include this kind of local loops for data reuse, data reprofiling.
I'm not sure I understand the question.
Yeah,
Sorry.
your data lifecycle is just show from the data from the proposal to the publication.
Yes.
But actually, you need to, if you want to reuse, you need still to provide some facilities and some functionality to have researchers access to the already archived data at different stages and reuse them.
Yes,
so
absolutely.
one of the model for data lifecycle include this kind of cycles.
Yes, no, that's true. And yeah, I mean, it's an oversimplified diagram, of course.
Okay.
Certainly that stage at the bottom, which is around computation, is a repetitive cycle that is done many times, bringing in data from everywhere. The collection term is often relevant here as well. Collection, by collection I mean bringing data together from different sources in order to do some particular piece of analysis. But the reason why that computation stage has not been covered thus far is because it's much more complicated. So it is a real piece of work to try and include that.
So we have a question right at the back. The microphone.
Hi, thanks. Robin Winsworth Saibera from Canada. Have you seen the tagging of data and the metadata starting to recognize or putting in fields who funded the work and who actually asked for it? And then have you started seeing that being used to give recognition to those who provide very reusable work, so that if somebody's providing a grant, they say, yeah, we like this guy because we saw that his work was reused another 20 times, so we got more bang for the buck, and that researcher getting recognition because he's providing very useful stuff to his peers. Is that happening, or do you see it happening more?
It's certainly one of the things we're trying to enable with the policy work on saying that appropriate recognition should be given. So that kind of recognition is certainly one of the things we would want to encourage. In particular, the 3,000 authors on a paper kind of model, just because that's the only way of recognizing 3,000 different contributions seems a rather blunt tool. We'd much rather like a kind of movie credits associated with a paper that says, data was collected by this person, the paper was written by them, the idea came from here, data was also used from this other research group over there, but they weren't involved in this analysis. A much more flexible system of giving recognition is what we're trying to support here.
Okay, so I don't see any more hands up, so I think we should thank Manu again.
Thank you.
So just before you disappear to the coffee break, can I remind you that during this coffee break, the authors of the posters will be available for you to discuss with them. So please take that opportunity to look at the posters they prepared. There are also, after the session, the next session, there at 6 o'clock this evening, there are various BOFs and workshops. So have a look at the agenda for things you may wish to join. And in case you haven't heard the news, if you need access to a printer, there is a printer by the main hall that you can either use physically or via AirPrint. So thank you very much to all of the speakers. Thank you to you for being here. Enjoy your coffee break. Thank you.